When you think of the giants of science, names like Newton, Galileo, and Leibniz probably come to mind. They were the architects of the scientific revolution in Europe, laying the foundations for modern physics, calculus, and astronomy. But what if I told you that halfway across the world, in a country deliberately sealed off from foreign influence, an entirely different scientific revolution was taking place? Welcome to the world of Wasan, Japan's hidden legacy of mathematics and astronomy, born from the minds of samurai, merchants, and monks. For over 200 years, from the 17th to the 19th century, Japan was under the rule of the Tokugawa shogunate. This period, known as the Edo period, was a time of national isolation, or sakoku. While the Dutch were allowed a tiny trading post in Nagasaki, Japan largely turned inward. It was a time of peace, and with the samurai class no longer needed for constant warfare, their sharp minds turned from the art of the sword to the art of numbers. This is where our story begins, not in a European university, but on the tatami mats of a Japanese temple. The father of this unique tradition was Seki Takakazu, often called Japan's Newton. Born around 1642, the same year Galileo died and Newton was born, Seki was a samurai in the service of a feudal lord. But his true passion was mathematics. Working independently, he developed his own form of algebra called Yendan Jutsu, or the method of the celestial element. This system allowed him to represent and solve complex polynomial equations, some with up to 1458 degrees. Think about that. It's a level of complexity that would challenge modern computers. He even discovered determinants before Leibniz, a fundamental concept in linear algebra, and calculated Bernoulli numbers before Bernoulli himself. How did he do it? Not with the Latin letters and symbols of Western algebra, but using a system of kanji characters written on paper or arranged on a counting board. What makes Wasan so fascinating is its approach. It wasn't just about abstract theory, it was a form of intellectual art and recreation. Mathematicians would hang beautifully painted wooden tablets, called sangaku, under the eaves of temples and shrines. These tablets weren't prayers. They were geometry problems, offered to the gods and as a challenge to fellow mathematicians. Imagine walking into a temple and instead of a religious verse, you see a complex geometric puzzle featuring circles, ellipses, and polygons, all intricately nested together. One famous problem, the Japanese theorem for cyclic polygons, states that no matter how you triangulate a polygon inscribed in a circle, the sum of the radii of the inscribed circles of the triangles is constant. It's an elegant and beautiful result, discovered completely independently of Western geometry. These sangaku were the Edo period's version of a public math forum, a vibrant, competitive, and deeply cultural expression of mathematical beauty. This problem-solving spirit wasn't confined to earthly geometry. The Japanese also looked to the stars. The shogunate needed an accurate calendar for agriculture and administration. The official calendar, imported from China centuries earlier, was becoming increasingly inaccurate. Eclipses were happening on the wrong days, and seasons were drifting. This presented a huge problem. So, the government commissioned a new generation of astronomers to fix it. Leading this effort was Shibukawa Shunkai, a master of Go who became the first official astronomer of the Edo period. Using his own observations and applying Wasan mathematics, he created the Yokyo calendar in 1684. It was a monumental achievement, the first calendar developed entirely in Japan, and it was far more accurate than its predecessor. It required sophisticated calculations of the movements of the sun and moon, proving that Japanese astronomy was not just borrowing from China, but innovating on its own. One of the most mind-blowing figures from this era is the philosopher and scientist Miura Bayan. Living in a remote part of Kyushu, Bayan developed a complex system of logic and a cosmological model that was shockingly modern. He theorized about a universe composed of fundamental particles, which he called Yori. that combined and separated according to specific principles. He conceived of a cyclical universe, expanding and contracting, and even wrestled with concepts similar to atomic theory and the conservation of energy. He did all this with no telescopes, no labs, just pure reason and the principles of Wasan. He was a true systems thinker, trying to find a single, unified logic that explained everything from the stars to human society. His ideas were so advanced that they were largely ignored in his own time, a forgotten genius whose notebooks reveal a mind grappling with the very fabric of reality. So, how did Wasan compare to Western science? It's a fascinating question. Wasan was incredibly strong in algebra and geometry, often solving problems that were at the cutting edge of European mathematics. However, it had its limitations. Because of Japan's isolation, it never developed the formal system of proof that became central to Western math after Euclid. Wasan was more about finding the answer and the elegant method to get there, rather than constructing a rigorous, logical proof from first principles. Furthermore, without the influence of Western physics, Wasan never made the leap to calculus in the same way Newton and Leibniz did. They had the tools, like Secchi's work on integration for finding the volume of solids, but they didn't connect it to motion and change, the very essence of physics. Their focus remained on static, beautiful problems, like the Sangaku puzzles. When Japan finally opened its doors to the world in the mid-19th century, during the Meiji Restoration, everything changed. Western science and technology flooded in, and Wasan was quickly seen as old-fashioned. The new government mandated the adoption of Western mathematics in schools, and within a generation, the unique tradition of Wasan was nearly forgotten. The Sangaku tablets were left to weather in the rain, their brilliant problems ignored. It was a calculated decision to modernize and catch up with the West, but it came at the cost of a unique intellectual heritage. As if a whole library of unique knowledge was simply locked away and the key thrown out. But the story doesn't end there. Today, historians and mathematicians are rediscovering the incredible achievements of these samurai scientists. They are translating old texts, solving the Sangaku problems once again, and recognizing the genius of figures like Secchi Takakazu and Mura Bayan. We're realizing that the history of science isn't a single, linear story that flows only from Europe. It's a rich, global tapestry woven with many different threads. The story of Wasan shows us that genius can flourish in the most unexpected of places, driven by curiosity, beauty, and the pure joy of solving a difficult problem. It is a powerful reminder that there are always hidden histories and forgotten pioneers waiting to be discovered. So the next time you look at a math equation, remember the samurai who traded his sword for a counting board, the merchant who hung a geometric puzzle in a sacred temple, and the astronomer who mapped the heavens to create a calendar for his people. They are Japan's hidden scientists, and their legacy is a testament to the universal human drive to understand the world around us. Thank you so much for watching. If you found this hidden history as fascinating as I do, please hit that like button. And subscribe for more stories about the forgotten corners of science and culture. Let me know in the comments what other hidden histories you'd like to see explored. Until next time, stay curious.